Hey guys, we're going to look at hot topic number 2. It discusses modeling functions and interpreting their meanings, sometimes referred to the context of the question on the regions. So we're going to look at question 1. For pretty much most of these questions, we're not going to need a calculator because they're more English-based or more understanding the context. So for question 1, it talks about a company that manufactures radios. They have to pay a startup cost and then a certain amount to manufacture each radio. So in the question it says, if the cost of manufacturing our radios is given by the function, then the value of 5.25 represents. Well, I'm going to write out the equation up here at the top of the paper. Now, the 125, in this case, they talk about how the company manufactures radios, they have to pay a startup cost. So 125 represents the startup cost, because it's only one time they have to pay that amount to kind of get all the parts or whatever they needed. Then it says the cost of manufacturing our radios. Now that's the clue right there. Once they tell us what R represents, then we can figure out what the 5.25 is, because those two are related to each other. So if manufacturing our radios is what they're talking about, that means that the 525 is going to be the amount for each one, which in this case be answer 3. So this is how much it costs for each radio to make one, because every time that you make a radio, R, it's going to cost you $5.25 more. So there's that constant rate of change. If you made 10, it'd be 10 times 5.25. If you made 20 radios, 20 times 5.25. The 125 is fixed, and the 525 is changing. That's why it has the variable R with it. Now, the other types of questions that you might see dealing with functions, and on the back of the front page, you will see sometimes you might see some exponential functions. And in the case of the first one on the back of the front page, it says the breakdown of a sample of a chemical compound is represented by the function. So this is the function, and I'm going to rewrite this. 0.5 T. It says P of T represents the number of milligrams of the substance, and T represents the time in years. Okay? So, when we're talking about an exponential function, there's two parts to it, and that's the part they want us to explain, what the 300 and the 0.5 represents. Well, the first part is the 300, and it says, in this case, it's a sample of a chemical compound. So the 300 represents the y-intercept. That's like kind of our initial amount. So the 300 represents the milligrams of the compound at the start. Or you could say when t equals 0. And then with exponential functions, they talk about a rate of change. In this case, it's not a constant rate of change, but the change is based on a percentage. So this 0.5 right here tells us two things. First off, it's losing amount because it's less than 1. So this would be, in this case, this would be exponential decay. And to figure out the percentage, because it's an exponential function, what you would do is it would be, in this case, since it's decay, 1 minus r. So in the case of this, it's 0.5. So that would mean that it would be 1 minus 0.5 would give you that 0.5 left. Now, the idea with this is that that 0.5 represents a percentage. So if you move the decimal 2 spaces, that's going to give you a percentage of 50%. So what that means is, for the 0.5, it means that we're losing 50% of the substance based on the amount of time. In this case, it's years. So a 50% loss each year. Okay. So, again, like I talked about it, it's more of a reading question, and you need to know what each amount represents. In this case of the exponential function, you got the y-intercept, which is your starting amount, just like on the linear function. But with exponentials, there's going to be some sort of percent of change that's going to happen. And then with the linears, you got the constant rate of change, which is next to the variable, and then the y-intercept. So those are the things you want to look for on these questions.